Suppose we are running a left-tailed test at a 5% level of significance. In every normal distribution, there's only one z-score that traps 5% on the left tail. It's z equals negative 1.645. We can call this z star, the critical z-score that must be exceeded by the test statistic in order to have a p-value less than 0.05 and reject the null. The z-score for the mean of 47.7 was negative 1.84. It's beyond the negative 1.645 threshold, where 0.05 is trapped, so it must trap less than 0.05. Sure enough, it trapped 0.0329. This gives us a second way to conclude whether we should reject the null. If p is less than or equal to 0.05, or if the test statistic, z, is less than or equal to negative 1.645. In a right-tailed test, a test for which the alternative is mu greater than some mean value, the test statistic for the sample mean was 1.51. At a 5% level of significance, can we reject the null? Well, z star would be positive 1.645. The test statistic is not beyond the critical z-score. Therefore, we fail to reject the null, and indeed, the p-value is 6.5%. Here are the four most common critical z-scores you could find using a z-table or inverse norm in the calculator. Suppose we run a right-tailed test and compute a test statistic for the sample mean of z equals 1.79. At what significance levels can we reject the null? Answer: 10% and 5%. To reach the threshold of p-values at or below 2.5%, we would need a z-score of at least 1.96. The two-tailed tests are a little trickier. If we got a test statistic of exactly 1.96, we know that there was a 0.025 chance of getting a sample mean at least 1.96 standard deviations to the right of the mean due to random chance if the null were true. And if the null was true, such a result would tempt us to reject the null, thinking the alternative was true. But in a two-tailed test, if the null is true and such a result just happened due to random chance, then 2.5% of the time we could get a result just as far below the mean, also tempting us to go with the alternative. Hence, in a two-tailed test, there's twice as much probability of exceeding a certain z-score than there would be in a one-tailed test. In our case, the p-value would be 0.05. So what is the critical z-score for a two-tailed test run at the 5% level of significance? It's z star equals plus or minus 1.96. Anything beyond this on either tail should only occur a combined 5% of the time due to random chance. Answer this: what is the conclusion to this test at a 10% level of significance if our test statistic is z equals negative 1.35? Answer: fail to reject the null because the critical z-score is the one that traps half of the significance level on each tail. The critical z star is plus or minus 1.645. We did not reach it.